Hello friends, in the introduction part we have already seen about engineering graphics or engineering drawing and the topics we are going to cover, and today I'm going to start this video lecture with a topic called projection of points, which is the most important topic to understand engineering graphics or engineering drawing. If you understand this topic properly, upcoming topics becomes very simple. This is completely concept oriented. Fine. This is most important, try to concentrate. So, projection of points. Here a small concept got implemented. What is that? We'll see now. For example, there is, as most of you are familiar with, we'll try to draw a horizontal plane, vertical plane, horizontal and vertical plane. Fine. But I'm drawing a line. I'm calling it as a plane. I'm drawing a simple straight vertical lines and a horizontal line, but I'm calling it as a plane. It acts as a plane actually, because if I try to extend, imagine that vertical plane nothing but transparent glass plate. Similarly, horizontal plane is also transparent glass plate. Fine. Now both those two are intersecting with each other. Fine. For example, this is vertical plane, this is horizontal plane. Both are intersecting, penetrating inside the other. Fine. They are crossing each other. I'll make a 3D view of the component or the planes. I'll try to make a 3D view. For example, the vertical plane will look something like this. This is the vertical plane. Similarly, a horizontal plane will look something like this. The intersection of these two will give you an XY line. Intersection of these two will give XY line. Fine. Now this is vertical plane. This is your horizontal plane. When I place the component normal to the person observing, means when I view from here, what happens? I could see only single line which is vertical from top to bottom. This line is visible only. When I view from here, what happens? This is the only line visible from the front. That is what I have drawn here. Similarly, this is the only line visible of a horizontal plane. Only line visible of a horizontal plane. That is what I have drawn here. In simple, in a 2D view, we'll try to consider a vertical line as a vertical plane, a horizontal line as a horizontal plane. Now meeting point of these two. Now here we could see in an isometric view, we could see x and y, where when I view from here, I could see only x, where y is coinciding with x. So this is not visible. So what we try to do, it look like a point in between x and y, in between VP and HP, it look like a point. So this point acts as x. Okay, try to understand. Now in the previous lecture of introduction, I have already discussed about first quadrant, this is second, third quadrant and fourth quadrant. Okay, we all already know the concept of quadrant system. From the school days, we are working like positive, okay, negative, positive, then again negative, and again positive, negative. We deal with these things in trigonometry or whatever. In engineering mechanics also, we deal with these positive negative terms. Whereas in this case, we only discuss about the quadrant system. We will try to divide this into 4 segments. For example, if some x component is placed in first quadrant, how does it look from the front and from the top? We will try to discuss all of them in this particular scenario. Fine. For example, there is a point A. I'll try to make a note. There is a point, for example, there is a point somewhere here. The name of the point is A. Let us assume, which is placed at a distance of x1, from horizontal plane. Again at a distance of x2 from vertical plane. There is an object A which is placed at so and so x1 and x2 distances from horizontal and vertical planes. How you draw the object A with respect to a reference line xy on your drawing sheet, because these two horizontal and vertical planes are maintaining 90 degrees angle with each other, which is not possible to place on a laid drawing sheet, because your drawing sheet is not maintaining 90 degrees. It is laid on a table. How to place this particular points, front view and top view, on that table? We'll see now. Try to understand a small concept here. Try to remember it forever. Whenever there is a vertical plane, horizontal plane, always assume that there is a person standing here. There is a person standing towards right of the complete system, watching the component. He is standing here, watching from here. This is the front view position. This is what? Front view position. Whether he is in the top or bottom, we call it as front view position. Fine. When you view an object from here, as you have a reference of vertical plane, the image or projection, the projection is going to fall on vertical plane. This is what? Front view position of the observer. Fine. Similarly, there is one more object by name B. When I view from here, how does it look like? There is a mirror or a vertical plane, transparent vertical plane in between observer and the object, which is a green line. So as it is transparent, from here I can't assume that the object is, whether the object is in front or behind. It is not possible from this position. We need to make some thumb rules in this video lecture of projection of points now. Unless you make a thumb rule, you don't understand the things properly. Fine. So this is what? Front view position of the observer. Similarly, this is top view position of observer. Fine. This is also top view position of an observer. So when I view from the top, there is an object A, B again. I can say that whether the object is in front or behind, whether object A or object B is in front or behind. That is very much easy. But I can't predict that whether the object is below HP or above HP. Why? Because it is a transparent glass plate. When the plate is transparent, when I am viewing from a distance, I can't predict whether it is below or above. Similarly, from this position also I can't predict whether the object is behind or in front. Try to make a note. So I'll try to make all the thumb rules here. I'll try to make a thumb rule. Fine. So here, from here, what you could see, front view. From front view, what you could predict, what you could justify is all about horizontal plane. You can only talk about horizontal plane. You can only justify about a horizontal plane, whether the object is above or below. These are the two things you can talk when you are standing in the front position or a front view position. Similarly, if you take a top view, what you could predict, you can talk about vertical plane only. You are not supposed to talk about any horizontal plane. You need to talk about vertical plane, because when I am standing in the top, I could justify only one thing, whether it is in front or behind the vertical plane. In front or behind the vertical plane. So what I could decide here, whether the object is in front or behind. These two thumb rules I can easily make now. When I am standing in the front view, above, below, I need to decide. When I am standing in the top view, I need to decide whether it is in front or behind, because we are dealing with transparent glass plates. These are the two thumb rules. Other than this, many more to come. If you remember this properly, everything becomes so simple. Okay. Now again I'll try to draw the same sketch here. Vertical plane, horizontal plane, vertical plane. This point is your x, y. So with respect to this point, on your drawing sheet you need to draw a xy line, followed by you need to place your front view and top view of an object. Now with this conclusion, what you can write here is, when the object is in first quadrant, for example, when the object is in first quadrant, what you could decide, whether the object is above or in front. What is the above distance, what is the in front distance. Okay. If it is in the first quadrant, what you can decide, whether the object is, you have to decide two conclusions you need to make. What are those two conclusions are? Above distance and in front. Above and in front. Only two things. Above and in front. Above from front view, in front from top view. Similarly, when the object in second quadrant, what you decide, what you talk about, the distances of, again second quadrant means this one, again above and behind. Above from front view, behind from top view. That is also important. So from front view, from where you decide whether it is above or in front, from where you decide whether it is above or behind. These two decisions you need to make from front view and top view. Standing in the front view, you can't decide whether it is in front or behind, can't be decided if you are standing in the front view. Similarly, above, below can't be decided when you are standing in the top view. Fine. Try to make these as a note. Okay. Similarly, the third quadrant, what you could decide, third quadrant, front, top. When you are in the front, what you could decide is below from the top, behind, third quadrant. below, behind. So from where? Below can be decided from front, below can be decided from front view, behind decided from top view. Similarly, fourth quadrant, you can talk about horizontal plane, below, then change your position to the top. So if you are dealing with fourth quadrant, it is in front, below and in front. So below is justified from front view and in front is justified from top view. This is also more important. Above, in front, above, in front, above, behind. I'll cut short it for your understanding. Below, behind, and below, in front. So it is very much clear now that whenever any object, whether it is a point, line, plane or a solid, if it is placed in the first quadrant, you need to know the distances of above HP in front of VP, above HP in front of VP. Fine. Similarly, second quadrant, above HP behind VP, third quadrant, below HP behind VP, fourth quadrant, below HP in front of VP. So always whenever you talk about quadrants, we are always talking about horizontal plane first, then vertical plane next. So if you are very much sure that we are talking about only horizontal plane, you need to talk about above, below. If you are talking about vertical plane, you need to talk about in front, behind, whether it is in front or behind. If it is in front, what is the distance? If it is behind, what is the distance? Fine. Similarly, if it is above, what is the distance from the horizontal plane? If it is below, what is the distance from the horizontal plane? This is all you need to decide. Fine. So again, I will make one more thumb rule. What is the thumb rule is? I will try to partition this. What is the thumb rule again? When you are standing in the top view, above, below, as I said, above, below can be decided, front view, top view again, in front, behind. Same thing I wrote here. Better we'll go to some problem solving. Fine. Roughly, I'll make a point here. The name is A. One more point, name is B. One more point, C. There is another point, D. We'll try to fix some dimensions, some conventional dimensions. For example, for this particular point A is placed at a distance of 20 mm by 25 mm, 20 by 25. Similarly, this point B at a distance of 20 by 10. Similarly, point C at a distance of 15 by 12. Point D at a distance of 10 by 15. Okay. Now these are the positions of A, B, C, D placed in different quadrants with different dimensions. How you place this on your drawing sheet which is laid on the table. So what I try to do is, for example, here you could see, as I said, XY acts as a reference line. I'll consider this XY, I'll try to place XY something like this on my drawing sheet. Okay, this is X, this is Y. Then again, I'll try to calculate A. Now here I am watching or observing the object from here, which is front view. When I am standing in the front view, what I need to talk about, whether the object is above or below. Now it is clearly mentioned that it is above at a distance of 20. Above what? Above XY, above HP, above XY line. Okay, here you could see above HP, above XY line. So 20 mm above XY line. Fine. Similarly, I change my position to the top. When I view from the top, the projection of this point going to fall on horizontal plane. When I view from the front, the projection of this point is going to fall on vertical plane. When the projection is falling on vertical plane, here the name of the point is A, capital A. Here I can name it as A, small a prime. Similarly, when I view from the top view position, the projection is going to be on horizontal plane. So top view A, top view is set as A only. This is A prime. The indication, what is the indication? How you notate? The notation is prime. Front view is always notated with a prime, and the top view without any prime. Okay, that is also one of the conclusion. Front view always denoted, or the notation is value or a number followed by prime. Top view is only a number or a symbol without any prime. Fine. Or you can call it as a dash also. Fine. Now I'll try to place these projection on XY plane. 20 above. Initially I'll try to draw the 20 mm dimension line first. I'll measure from here, I'll measure 20. I'll try to draw one locus up to some infinite distance. Then 10 mm away, I'll try to make a point. 10 away, I'll try to make a point. Okay. Then again, when I view from the top, the projection is going to be on the horizontal plane, and here a small concept exists. When it is maintaining 90 degrees inclination, you can't lay it on your drawing sheet. That is a reason for convenience. What they did is, they have rotated. We need to rotate the horizontal 90 degrees clockwise. Then what happens? When I rotate horizontal 90 degrees clockwise, this line will come and align with or mate with vertical plane. Then what happens? Obviously, this point will also come and meet with vertical. Then both A prime and A fall on a single vertical. A prime and A fall on a single vertical. That is the reason, because we can't draw this 90 degrees projections A prime and A on a flat laid drawing sheet. That is the reason we are trying to rotate horizontal 90 degrees clockwise always, to mate with a vertical plane where your projection will also rotate 90 degrees clockwise and come and meet with the vertical plane. Now here you could see A prime and A falling on a single vertical. Now this distance of A is equivalent to 25, is equivalent to this 25, because it is rotating. So center will remain same. So this distance 25 is equal to this distance 25. So we need to consider that 25 also. I'll try to extend the dimensions below, which is 25. I'll draw one more locus. 2H line. Everything has to be drawn with 2H pencil only. Okay. Afterwards you can use HB. I'll tell you how. Again, this is the point you made. So draw a projectile line with 2H pencil till it meet with 25 mm. Once it is met with 25 mm line, take a HB pencil. Our intention is to show the projection of a object. Here the object is A. It is only a point that need to be highlighted. That need to be highlighted. Fine. Now here this is your front view. Above is your front view. So here you can call it as A prime. Below is top view. You can call it as simple A. Front view, top view. So we are dealing with first quadrant. In first quadrant, here we can make one more conclusion, that in first quadrant, front view is always above XY line and top view is always below the XY line. Now we'll take second question, which is B. B is the object, and again I'll come to the front view. As it is a transparent glass plate, I can view this object from the front view. Now when I view from the front, I need to talk about horizontal plane only. According to our thumb rule, I need to talk about horizontal plane. When I talk about horizontal plane, the object B or the point B is above 10 mm above HP. Fine. So obviously it is 10 mm above XY line. So I'll try to place the 10 mm here with a 2H pencil. I'll draw one locus. This is 10. So when I view from the front, the projection of point B is going to be on vertical plane, because vertical plane is in between the object and the observer. This is your point B prime, because it is the front view. When I view from the front, I could see a distance of 10 mm above HP. So I'm making it as B prime. The object name is B. Similarly, I'm changing my position to the top. When I view from the top, I could see the projection of B on the horizontal plane. As it is a top view, I need to notate simple B. And when I rotate horizontal plane 90 degrees clockwise, this will also rotate. This will also rotate, and whatever the distance it is maintaining 20 with respect to vertical plane, same need to be placed here. Okay, same distance it is maintaining with respect to vertical also. So here object got shifted here. When it is horizontal plane is rotated 90 degrees clockwise, the object also shifted to the vertical. So B prime and B both are falling on a vertical plane, both are falling above XY line only. Already I have mentioned 10 mm. Now 10 mm away, I'll try to mention one more dimension line which is maintaining 20 mm. Okay, this is 10 mm, this is 20 mm. On a 10 mm locus, we need to place a B prime, which is front view. On 20 mm locus, we need to place B, which is top view. Okay, at a distance of 10 mm away from the dimension line, I'll place object B, which is B prime. Similarly, here B, which is top view. So you can draw a vertical from top to bottom with 2H pencil. Now dot need to be enlarged. This is front view, this is top view. Similarly, front view, top view. So in second quadrant, what happens? Try to concentrate. In the first quadrant, this is about first quadrant. In the first quadrant, front view is above, top view is below. In the second quadrant, both the views are falling above the XY line. This always happens. Okay, try to remember. We will see third problem, or thought we'll solve the object number C or point number C. Here is my position, which is front view. When I view from the front, there is a vertical plane between the object and the observer, but when I view from here, as it is a transparent plane, I could see this point on the reference plane VP having a distance of 15 from the horizontal plane. So when I am standing in the front view, I need to talk about horizontal plane only. So here I can decide that it is below the horizontal plane. At what distance is already given? 15 mm below the horizontal plane. Fine, 15 mm below means obviously it is below XY line only. So what I try to do is, I'll try to make a point here. I'll try to draw a dimension line of 15, draw one locus, this is 15. Now when I view from here, the projection of this point going to be on vertical plane again. The name is C, so as I am viewing from the front, this is my front view, so here I name it as C prime, because the name is C prime. As it is front view, need to be represented with a prime. Similarly, I change my position to the top. When I view from the top, I could see this distance 12 mm with respect to VP. So the projection of C is going to be on horizontal plane, which is C. When I view from the top, I could see this distance, or I could feel this distance of 12 mm from the top, okay, which is falling on the horizontal plane, because there is a horizontal plane acting as a reference between the observer and the object. Okay, here is the point. When I rotate the horizontal 90 degrees clockwise, this will come and join or meet with vertical plane again. This is what C, which is your top view. Okay, here what is happening, when I view from the front, I could see the projection C prime, which is front view, on a vertical plane, again C on vertical plane when you rotate 90 degrees clockwise. So both are falling on a same vertical, okay, same vertical line, but the top view is coming above this time, front view is coming below. C prime below, C above. How to place that? Above, what is the distance? Above distance is again 12 mm. So here I'll try to place a 12 mm line again. I'll try to increase the length. Okay, draw one more locus. Fine. 10 mm away, I'll make it 15. 10 mm away, again I'll make a mark. I'll draw a locus from top to bottom. Projector line, so not locus, sorry. Projector line from top to bottom. Wherever it meet with the 15 mm dimension line, make one more point. Try to enlarge the point. Darken the dot. Now above XY line is C. If it is C, it is the top view. Below XY line is C prime. If it is C prime, it is front view, because prime is a front view. Fine. What is the difference you find between first and third quadrant? This is about third quadrant, no? The difference between these two is views are reversed in these two cases. Above front, below top. Here below front, above top. That is the only difference. So whereas in this case, as I said in my introduction also, both the views are colliding with each other. As these two are simple points, no problem. When you are dealing with very big component, intricate shaped component, if these two meet with each other, then you can't predict the views, you can't predict the curves, you can't predict anything out of that particular sketch. That is the reason in most of the 3D modeling, in engineering practice only, in complete engineering practice, we'll try to eliminate, when you deal with a 3D model, we'll try to eliminate second quadrant. We only deal with first and third. We even eliminate fourth quadrant also. Why, we'll see now. Why we eliminate fourth quadrant, we'll see now. Talk about D. I'm coming to the front view. I need to talk about horizontal plane. Now point D is placed below the horizontal plane at a distance of 10 mm. Below horizontal at a distance of 10 mm. So the projection of this point is falling on this reference vertical. As I am viewing from the front view, notation is D prime. Similarly, changing my position to the top to view point D. When I view from the top, this particular point D, the projection is going to be on horizontal plane, which is, now as I rotate 90 degrees clockwise, this D slowly come and meet with the vertical plane. Now you could see D prime, D, both are falling on a same vertical below the XY line, below the XY point or a XY line. Okay, that is the problem here. In this case, second quadrant, both are falling above. In this case, fourth quadrant, both are falling below. Okay, let us draw on a XY plane or a line. Now what is the distance? 10 mm below HP. So from here I'll make a mark of 10, draw one locus. Similarly, when I view from the top 15, so at a distance of 10 mm distance, I'll draw 15 mm line also. Okay, draw one locus, and at a distance of 10, one more point, draw a projectile line. Now wherever that projectile line meeting with both the locuses, try to enlarge or try to darken your point. Here is one more. Now which is the front view? Distance 10 is front, so this is your front view, which is represented with D prime. This is your top, represented with D. So in actual practice, what we try to do is, we'll try to eliminate in engineering practice second quadrant and fourth quadrant when you deal with bigger components. Concept wise it is okay, but when you deal with a knuckle joint, when you deal with a crankshaft, couplings or any other assembly, these two will give you a confused view which is not possible to predict. Fine. So here is the conclusion. This is your front view, top view, front and top, front view, top view, front and top. That is the reason we eliminate these two. This is about projection of points. Okay. If you remember these thumb rules properly, everything becomes very simple. If it is a point, this is a case. If it is a line also, everything becomes so simple. Fine. The concept is more important rather than drawing it. If you understand the concept, whatever the question given, you can attempt it very much easily. Furthermore, you can find the link in the description below. Thank you for watching. If you have anything to ask, any doubts, please comment. We are here to solve your problem.